This question says, given triangle ABC is similar to triangle DEC, solve for X. All right, this question is harder because the triangles are inside of each other. So it's actually probably easier to think about this as two separate triangles. Now, before I draw them as two separate triangles, I'm going to show you actually two ways to do this problem. Actually, I'll probably show you with two triangles first. All right, so let's do that one. Here's my first triangle, my big triangle. So this is A, B, C. And this is my second triangle, my smaller triangle. So this is D, E, C. All right, and if I just really quickly do some coloring on the sides to match them up, I know that AB needs to go with DE. So AB, this piece, needs to go with DE, this piece. I know that, different color, I know that BC needs to go with EC. So BC, this side, needs to go with EC, this side, and then AC needs to go with DC. Okay, so in the little triangle, I have that EC is 5, so I'm going to put a 5 here, and I have that DC, the bottom, is 7. On the big triangle, it's a little bit harder because BC is actually this whole thing. This whole thing. So it would be piece plus piece. So it'd be x plus 3 plus 5. And when you combine those like terms, you'll get x plus 8. All right, and then AC, the bottom, is this piece plus piece. So that would be 2x plus 7. All right, and so then you could set up your proportion just from this. You could say green over green equals red over red. So you could do x plus 8 over 5 is equal to 2x plus 7 over 7. And so you would cross multiply. You would do 7 times this whole thing and 5 times this whole thing. So you'd have 7 times x plus 8 is equal to 5 times 2x plus 7. Now I'm going to do the algebra kind of fast because I want to show you another way to do this problem. When you distribute here, you'd get 7x plus 56. When you distribute here, you would get 10x plus 35. And when you subtract 7x, you'd get 3x. And when you subtract 35, you'd get 21. And you divide by 3, and you'd get x is equal to 7. All right, so that's what I got whenever I drew two separate triangles. The hardest part about doing that is remembering that this whole side is piece plus piece. Because people will just put the x plus 3 up here, or people will just put the 2x down here. They'll forget that these pieces go together. But that doesn't necessarily have to make you miss these kind of problems. Because one of the kind of cool things about when you have similar triangles that are stacked inside of each other like this, I know that this line is going to be parallel to this line, and that actually makes all of these pieces proportional. So you could have done x plus 3 over 5 equals 2x over 7. You could have done x plus 3 over 2x equals 5 over 7. There's lots of different proportions that you can set up when you have similar triangles inside of each other. So for instance, if I had done x plus 3 over 5 is equal to 2x over 7. That's the little piece over the long piece equals the little piece over the long piece. And then I cross multiply, you're actually going to find out that you get the exact same answer either way. 5 times 2x is 10x, and 7 times this whole quantity, I'm going to distribute the whole thing, I get 7x plus 21. And then you subtract 7x, you get 3x equals 21 again, and then you divide by 3, and you still get x equals 7. So the cool thing is that there's lots of different ways to do these problems.